Hello again. This is the problems 5 through 7 on your rational review. We're going to be solving for all our properties: vertical asymptote, holes, horizontal asymptote, zeros, and y-intercepts. Remember, the first thing we need to do is look at our equation and factor it as much as possible. I'm going to show the factoring over here on the right. We've got x squared minus 2x minus 8. So we're looking for things that multiply to give us negative 8, but add to give us negative 2. In this case, it's going to be x minus 4 times x plus 2. We also need to factor the denominator. And looking at this, I recognize this is the difference of two squares. So I know my factors are going to be x plus 2 and x minus 2. Ran out of room there. All right. We do have two terms that will cancel. X plus 2 is on the top and the bottom, so we'll cancel those. And now looking for our vertical asymptote. We're looking for what was not canceled on the bottom, x minus 2. And we set that equal to 0. Solving gives us x equals positive 2. We find our holes by looking for the terms that were canceled. So x plus 2 is equal to 0. Solving that gives us x equals negative 2. Horizontal asymptotes. We find our horizontal asymptotes by looking at the degrees in our original equation. We have an x squared term in a numerator and an x squared in the denominator. So our horizontal asymptote is going to be the ratio of their coefficients. So y equals 1 divided by 1, which equals 1. Zeros, also known as our x-intercept, we find by solving for the top part of our equation by setting it equal to 0, any parts that we didn't cancel. So we have x minus 4. We set it equal to 0 and get x equals positive 4. That's our x value for the x-intercept. The y is a 0. Y-intercepts are found by setting every x in your equation equal to 0. Coming back to our original equation, anything with this x in it I will be crossing out. 0, 0, 0. So what we're left with is negative 8 divided by negative 4. That's going to give us a positive 2. And we're done with the first problem. Okay, number 6. Exact same issue. We've got to factor this and then solve for all our pieces. Our first part, and I will write it over here so we can see it clearly, we need things that multiply to give us negative 18, but add to give us a positive 3. X plus 6, x minus 3. And again, knowing your multiplication tables help speed this process up. On the bottom, we have a greatest common factor, which is an x. So as I factor the x out of each term, or divide by x, I'm left with x minus 3. And my x minus 3's will cancel here. So my vertical asymptote, I take whatever is left on the bottom, which is x, and set it equal to 0 and solve. In this case, there's no solving to do, as x is equal to 0. My holes are found by taking the parts that do cancel and set that equal to 0. So x minus 3 equals 0. So x equals positive 3. Okay, our horizontal asymptote. For the horizontal asymptote, again, we're going to look at the ratio of our terms. We have an x squared and an x squared. This is the same as the previous one. The same exponents, so we look at the ratio of our coefficients, which give me 1 again. 1 divided by 1 equals 1. To find my zeros, I take what's left in the numerator, so the parts that were not canceled, in this case it was x plus 6, and set it equal to 0. I solve for x, so I get negative 6, and the y value is 0 for my x-intercept, or 0. My y-intercept I find when the x value is 0, so I know it's going to be 0 comma something, and to find it I plug 0 in for every x. Cross out whatever was left, so I'm left with negative 18 divided by 0. Now we know that's undefined, so we will not have a y-intercept. This will be undefined. Okay. All right. Question number 7. Is x equal to 3 part of the domain of this function? Well, what it's asking is, does this function exist when x equals 3? So if we plugged in 3 for x, we would have 1 divided by 3 minus 3, which is 0. That cannot exist. That's our asymptote. So no, the function has an asymptote at x equal to 3. So we know our function never actually touches or contains a value where x equals 3. It gets closer and closer, but it never touches this or reaches it. Okay, thank you.